Hello everyone. Today we are going to study the histogram modeling. So, histogram of image, it provides histogram of image provides the global description of the appearance of image. So the global description of appearance of image is provided by this histogram of an image. By definition, this histogram of image represents the relative frequency of occurrence of the various gray levels of an image. So we know that in grayscale image there are various gray levels present. So out of that the relative frequency of occurrence of an image is represented by the histogram of an image. Now to plot this histogram there are two methods. So first method, this is very simple and traditional method where we can plot on one axis we are going to plot the number of pixels, while on other axis we are going to plot the number of gray levels. So this axis represents number of pixels and this axis represents the grayscale or gray level. Let's consider this is 0, 1, 2, 3, 4, 5 and 6. This point is 6, like this. Okay, and we are having a table. That table gives us the information of gray level and number of pixels. Suppose we are having gray level 0, 1, 2, 3, 4, 5 and 6. For gray level 0 we are having 40 pixels, for gray level 1 20 pixels, for gray level 2 10 pixels, for gray level 3 15 pixels, for gray level 4 10, for 5 3 and for 6 2. Then we can plot for gray level 0 we are having total 40 pixels. So this is the way. This is for 20 pixels. Here are 10 number of pixels. Here are 15 number of pixels. Then next one is 10 number of pixels, 3 number of pixels and 2 number of pixels. So by this way the graph is plotted of for the number of gray levels versus the number of pixels. So this is the one method by which we can plot the graph. So this is the table for number of pixels versus the gray level, and it is method 1 which is very simple. In method 2 what happens, instead of plotting directly the number of pixels versus gray level, here the probability of occurrence is calculated. So that probability of occurrence can be calculated as PR RK is equal to NK divided by N, where this RK is nothing but kth gray level. In image number of gray levels are there, out of that kth gray level is represented by RK. Then this NK is nothing but number of pixels in kth gray level, and this n is nothing but total number of pixels in an image. Okay, so for example, we are having the previous table. So in that we have seen that for gray level 0 we are having number of pixels nk equals to 40. So this nk will be 40 and gray level will be 0. So this rk is represented as r0. So this is the gray level 0, and for that we are having total 40 number of pixels. So this is method 2. So we'll write down here. So this is our previous table. We'll use this same table here. Now here we have to only add one more column that indicates PRRK, that is the probability of occurrence, which is equal to nk divided by n. So n is nothing but the total number of pixels present in the image. So if we do the addition of all these number of pixels, the addition will be 100. So probability of occurrence for gray level 0 will be calculated as nk, means 40 divided by n. So here I will write down probability for occurrence of r0 will be 40 divided by n, means 100, which will be equals to 0.4. So likewise we can calculate the probability of occurrence. So here it is 0.2, 0.1, 0.15, 0.1, 0.03 and 0.02. So this is the table for method 2, and with the help of this table we can plot our histogram like this. This is nk and this is our gray level. Let's consider in short r. 0, 1, 2, 3, 4, 5, 6. Okay. So for gray level 0 we are having 0.4. So let's consider 0.4 here. So it is 0.4. For gray level 1, 0.2. For gray level 2, 0.1. For gray level 3, 0.15. For gray level 4, 0.1. For gray level 5, 0.03, and for 6, 0.02. So it is 0.4, 0.2, 0.1, 0.15, 0.1, 0.03 and 0.02. So this is the histogram by using our second method, where we are going to calculate the probability of occurrence of the particular gray level. Here the main advantage of using this method is nothing but here the maximum value which can be plotted on this graph will be 1. So the main advantage of this method, that the maximum value plotted will be 1. Okay, and this is the main advantage of this second method. Now we'll get a great deal of information by observing this histogram. So this histogram gives lots of information about images. Only by watching the image we can get great deal of information from that histogram about the images. For example, let's consider one image like this, sorry, not image but histogram like this. This histogram is having, this is PRRK. Wait a minute, in previous case it will be not NK, but here it should be the PRRK. Okay, so here it is PRRK and this is gray level R. So if we are having the histogram like this is the histogram for one case. For second case we are having the histogram like this. This one will be the histogram for third case and this will be the histogram for fourth case. Okay, 4 histograms I'll plot here. So this is A, B, C and D. Second histogram is having like this. Third histogram is having like this and fourth histogram is like this. Okay, so by only observing the histogram we can identify how our image looks. So if we observe the diagram A or histogram A, here if we observe the number of pixels of the image, that number of pixels are concentrated towards the dark side of the gray level. That's why we can say that the histogram A is of dark image. So histogram A belongs to dark image since all the pixels are towards the dark side of the gray level. Okay, so this is gray level 0 and this will be the maximum gray level. Suppose for 8-bit image the maximum gray level will be 255. So here we can observe the maximum number of pixels are towards the darker side of the gray levels. That's why the first histogram belongs to dark image. In second case, if we observe the number of pixels are concentrated towards the bright side of the gray levels. Okay, that's why the second histogram belongs to bright images. In third case, it is having limited range for the grayscale, and that's why this type of images which are having such type of what we can say that histogram, that images are called as low contrast images. And if we observe the fourth histogram, here the gray level will be distributed in among all the pixels, means all the gray levels are having few number of pixels in the image. That's why this is called as high contrast, or we can call it as a good image. So generally the histograms of fourth type are the histograms of good images. So these are the good image histograms. Our aim in this histogram modeling is to convert first 3 type of images into the fourth image, means we have to convert the dark image, bright image and low contrast images into this high contrast or good images. Now in first case today we'll see what do you mean by linear stretching. Linear stretching. Now as we have seen in this slide that main aim is to convert dark, bright or low contrast images into the high contrast image. That means here we have to increase the dynamic range of our images. So we have to increase dynamic range of images. Okay, and the one method to improve the dynamic range is nothing but the linear stretching. Okay, so what happens in this linear stretching, or it is also called as histogram stretching. So in this histogram stretching, what happens, suppose our histogram is having shape like this. So this linear stretching or histogram stretching, it is going to stretch the histogram. So this is the minimum value and this is the maximum value of our original histogram. So this minimum and maximum value is stretched from 0 to maximum value, that is L minus 1, and we'll get the histogram like this. Okay, so actually this value and this value will be the same value, or I'll redraw this graph like this. So this is nothing but linear stretching or histogram stretching. So how we can perform this histogram stretching, that we're going to study. So first of all, what we have to do, we have to identify one transformation so that we can convert the main or original histogram into the stretched histogram. For that, we'll consider the graph like this. Let's consider this is our original gray level R, this will be our modified gray level S. So this point will consider as R min, this point will consider as R max, this point will be S min, and this point we'll call it as a S max. So in linear stretching, the basic shape, it does not alter. So basic shape of histogram remains same, and with the help of such type of transformation we can convert our histogram into the linear stretched histogram. So here R min is the minimum gray level of input image, R max is the maximum gray level of input image, S min is the minimum gray level of output image, and S max is the maximum gray level of the output image. Okay, so here by using such type of transformation we can find out the transformation equation as S is equal to T into R, where R is the original gray level, S is the new or modified gray level, and T is our main transformation parameter. So here we can write down by using this straight line, will identify this transformation. So that will be S max minus S min divided by R max minus R min into the bracket R minus R min plus S min. So this is our, what we can say, the transformation or the equation for this linear stretching. Now we'll solve one example based on this linear stretching. Let's consider or perform histogram stretching. For that, let's consider one table like this. Here it is gray level and number of pixels, gray level 0, 1, 2, 3, 4, 5, 6 and 7. And the number of pixels are like this: 0, 0, 50, 60, 50, 20, 10 and 0. So first of all we'll draw the original histogram. These are the number of pixels nk. So for 0, 0 number of pixels, for 1, 0 number of pixels, for 2, here is r. So for 2 there are 50 number of pixels, so here is the 50, let's consider. For 3, 60 number of pixels, for 4 again 50 number of pixels, for 5, 20 number of pixels, for 6, 10 number of pixels, and for 7, 0 number of pixels. So this is our original histogram. So if we observe this original histogram, we can understand that for gray level 0, 1 and 7 there are no any pixels available in the image. So what we have to do, we have to stretch this histogram in such a way that the image should have all the gray levels from 0 to 7. Now we'll use the equation. This particular equation we'll consider. I'll write down here the equation. This is our equation. Okay, so from our given data we can write down the original minimum value, that is r min. How much is r min given? So r min is 2, that is nothing but minimum gray level available is 2 and maximum gray level available is 10. So r min is 2, r max is nothing but 6. Now we have to keep s min equals to 0 because we have to stretch our histogram from 0 to maximum value 7. Okay, so s min will be 0 and s max will be 7. So this transformation will be s max minus s min, that is 7 minus 0 divided by 6 minus 2 into r minus 2 plus 0. So it will be equals to 7 divided by 4 into r minus 2 plus 0. So I'll keep this like this. Now we'll make a table. Here is r and here is s. So 0, 1, 2, 3, 4, 5, 6 and 7. So when r is equal to 0, our s value means here at the place of r we have to put our this actual value. So it will be, I'll show you one example. For r is equal to 0, s will be equals to 7 by 4 into 0 minus 2. So it will be equals to so here what we have to do, first of all we can't use this expression. First of all, for 0, 1, so minimum gray level available will be 2 and maximum gray level available is 7. So we have to, these are having 0 number of pixels, so we'll ignore that because these are having 0 number of pixels. So when s is equal to 2, okay, so when r is equal to 2, in that case we have to find out the value of s. So s will be equals to 7 by 4 into 2 minus 2, so it will be equals to 0. For this 2 we are having 0. Similarly for 3 we can calculate, that will be equals to 1.7, so nearly we'll consider the value 2. For this 4 we are having 3.5, so we'll consider 4. For this 5 the maximum value we are getting is 5.2, so we'll consider it as 5. And for this 6 we are having value equals to 7. Okay, so I'll write down here separately. So r when r is equal to 2, 3, 4, 5 and 6, we are having s will be equals to 0, then 2, 4, 5 and 7. Okay, and our table is like this: gray level 0, 1, 2, 3, 4, 5, 6. Okay, so gray level, and here the number of pixels. So what we have to do initially from table, for gray level 2 how many pixels are there, that number of pixels we have to assign to gray level 0 in our new table. Okay, so if we refer this, at gray level 2 we are having 50 number of pixels, so that 50 number of pixels we have to assign to gray level 0. So for gray level 0 we are going to assign 50 number of pixels. Here for gray level 3, from the input image how many pixels are there, 60. So that 60 number of pixels we have to assign to gray level 2. Okay, similarly for gray level 3 we have done for gray level 4 how many pixels are there, 50. So that 50 number of pixels we have to assign to gray level 4. Then gray level 5 number of pixels we have to assign to gray level 5 in our new image, so it is 20. Okay, and for this gray level 6 we are having 10 pixels. So for this 5 we are having 20 pixels, and this gray level 6 is having initially 10 pixels, so that 10 pixels we have to assign to our new gray level, that is gray level 7, and rest of the gray levels we have to assign value as 0. Okay, so by this way we can draw the new or modified table for the histogram stretch. So here we have drawn the modified table for the histogram stretching, and here we can draw the new histogram like this. Here it is now modified gray level S. Here will be the number of pixels nk. So for 0, 1, 2, 3, 4, 5, 6 and 7. For gray level 1 0 number of pixels, for gray level 3 0 number of pixels, and for gray level 6 0 number of pixels. For gray level 0 we are having 50 number of pixels, so these are the 50 number of pixels. For gray level 2 we are having 60 number of pixels. For gray level 4 we are having 50 number of pixels. For gray level 5 we are having 20 number of pixels, and for gray level 7 we are having 10 number of pixels. So this is our new histogram. Now we can compare our original histogram with the new histogram. This is our original histogram. And this is our new histogram. So if we compare here, you can see that the shape of histogram is maintained as it is. So initially we are having the shape like this. Our histogram is having this particular shape in our original image. So this is original histogram and this is new histogram. The shape of new histogram is same like our previous histogram. So here we can say that in histogram stretching, the histogram can be stretched, or the number of gray levels can be stretched from minimum to the maximum, but the shape of histogram remains same. So here in this session we have studied about the histogram stretching. So thank you for watching the video.